Let's take a deep and wide look at the pillars of the maker movement, I mean, the big ideas underlying the movement. We will start with a keynote address from a person that I really admire a lot. It's Mark Frauenfelder. Where are you, Mark? Come on the stage. Editor of Main Magazine, contributor and editor of Boing Boing, and so many other things. Come on, up to you.
Hey everybody, it's great to be here. I'm going to be talking about what really is a maker singularity. And I'm going to start out first by talking about making over the last 100 years or so. And it's interesting to see how things really haven't changed in one way, and recently how they've changed a lot. So let's start in the year 1900. And these are statistics for the United States. I'm sure they're similar for Europe, but in 1900, 80% of Americans either lived on farms or worked on farms, which is pretty incredible, especially when you compare it to now, and only 2% of Americans live and work on farms. So what does that mean? It means that our country was really a country of makers. And I'm sure that's globally as well. We were makers by necessity because farmers had to have workshops on their farms. They were far away from urban centers. They had to have their own machine shops. They had to make all sorts of things. And let me see if I can get the next slide here. I was looking at some old farming implement catalogs from around that time. It's really interesting. You could literally remake civilization from scratch after a zombie apocalypse with one of these catalogs. They're like 300 pages long and just loaded with these incredible contraptions. And so these farmers, they were really busy, but as they started moving to urban centers, they started to have a little more leisure time. And there was this guy named Hugo Gernsback. He's also known as the father of science fiction. He created a magazine called Amazing Stories. But at that time, he also created a bunch of magazines to serve the maker hobbyist movement of the early 20th century. And I think this is a picture of Hugo here, sitting here looking at the equivalent of a widescreen television set of the day with his remote control. But look at some of these magazines that he made. Amazing Stories, The Electrical Experimenter, The Experimenter, Science and Invention. And so I took a closer look at some of the magazines that he made. Look at the projects that were available in the Electrical Experimenter between 1917 and 1918. These are exactly the kinds of things you would see in a Make magazine today. Wireless transmission of power, free electricity from the wind, a radio-controlled model boat, electricity to prevent future fuel crisis, and utilizing burnt-out lamp bulbs. This is exactly the kind of stuff. So I decided to take an even deeper look at some of these magazines and see what was in them. This is Radiocraft magazine, and you can see this is a parabolic microphone. It's the kind of thing that you can set up and hear nature sounds. This guy's listening to bird calls. And when I saw this magazine, or when I saw this cover, it reminded me of a project we had done in Make magazine. This is a parabolic microphone that you can make from materials that you buy at a dollar store. It's like a small umbrella. You can see a paint roller there, and you can see a cell phone wireless headset on there. This is a radio hat from the 30s. Everybody had one of these in the 30s, I'm sure. And again, when I saw this thing, it reminded me of something that we had in Make. This is like a hat synthesizer combination. So as you can see, there's like these parallels. We've been doing the same things in the past as we're doing now. When people started moving into the suburbs and they had more room to roam around with their projects, go-karts were really popular. This one appealed to me because it's a battery-powered go-kart. It's electrical. And once again, we featured something quite similar in the magazine. Even down to the red wheels and the tires. And you can see that the guy driving it is being less safe and more safe at the same time. This is a cover from Science and Mechanics magazine, building a suitcase-sized power cycle. It's a giant-sized suitcase. That's how they got away with saying that. But we had a very similar project again in Make magazine. This is an awesome scooter that you can make from a 36-volt battery-powered drill driving the scooter. And we had one of these things around at the Make office, and the low-end torque on this thing is incredible. When I sat on it, just like scooted right out from under me, and I landed right on my butt. teaching her wireless. You can tell the guy's really interested in teaching her Morse code. But one thing I noticed about maker fairs, and I'm sure you'll notice when you're here, is that making is a really popular couples activity. Families do it, couples do it. It's a really fun group activity and a way for people to get together. So I've kind of divided the what I call the modern maker movement into two phases. We're still doing the same kind of thing that we were doing 100 years ago, making cool things for ourselves, putting them online, showing instructions on how to make them. But we've also got this other phase that I'm calling phase 2, and this is where the maker singularity comes into it. Makers are making things for makers to make things. And when that kind of thing happens, you really see this innovation curve start to shoot up like crazy, because what happens is you're getting what's called the end of organizational advantage. Typically, if you wanted to make something cool that was kind of complex and sell it, bring it to market, you needed the power of a large organization behind you, like a Sony or some kind of consumer electronics corporation, to do all these various things here, R&D, design, funding, all those kinds of things. But what's happened is DIYers makers are not only so excited about making things, they're also excited about coming up with alternatives that are low cost and powerful at the same time to accomplish all of these things. So there are actually DIY versions of R&D, design, material sourcing. All those things are available very inexpensively, if not for free, and they are very powerful. And when that kind of thing happens, as it's happening now, we're really seeing some incredible changes in the world of making. So I went to Google Images and I typed in remote control lawnmower. And these are all the first images that I found for remote control lawnmower. That's really interesting. About 10 years ago, if you wanted to build your own remote control lawnmower, it would have been very difficult to do that. You couldn't go around your neighborhood and knock on doors and ask people if they built remote control lawnmowers, because no one else would have. But if you go online, you can immediately get access to the 1,000 people around the world who've built their own. And not only can you find out about them, they are more than likely very happy to talk to you about it, show you how they built it, help you realize your dream of building a remote control lawnmower. Another great R&D example are maker spaces that are growing up all over the world. This is places where people pay a fee to join basically a club. They get together in a space, they pay this fee, it pays the rent on the place, they can get equipment, CNC equipment, laser printers, laser cutters, 3D printers. The best thing actually though is that they get access to other people, other makers who have other disciplines, and they can cross-pollinate ideas and come up with really cool things, and I'll show an example of that a little later. In the world of design, DIY design, when I started as a mechanical engineer in the 80s, I was designing disk drives, and I was using a system that was super expensive to just do these simple wireframe models, and you had to pay by the hour to use the software. Now you can get SketchUp or a number of other software, 3D design software packages for either nothing or $100 and do all sorts of things with it. This software, SketchUp, is literally 10,000 times more powerful than the CAD software I was using in the 80s, and it's free. Here are some of the things that people can have designed and uploaded to digital model libraries so other people can download them and modify them to their heart's content. It used to be really hard to find materials for your projects too, but when the internet came along, the internet itself became an index surplus store. I went onto eBay, I was looking for photoresistors, and I found that you could buy 20 photoresistors for $2, including shipping, and it was sent from Hong Kong to my house in Los Angeles. I have no idea how they can make a profit on sending something from Hong Kong to Los Angeles for $2, but there you go. Prototyping, I don't have to tell you how 3D printing has changed that world of prototyping. Again, when I was a mechanical engineer, it would take 3 weeks to a month to make a form and fit prototype of, say, a base plate cover for a disk drive. I'd have to drive it across town to a model shop. They'd make it. There'd be something wrong with it. With 3D printing, you can just iterate really quickly and get your mistakes out of the way, and that really changes everything in the world of innovation. Arduino is an amazing prototyping tool. We're going to be hearing more about Arduino. I like to think of it as a way that anyone can design circuits that normally would require an electrical engineer to do. You can do all sorts of things like build this reverse geocache puzzle box. It's a box that opens only in one place on the planet. This guy Michael Hart made it. It's a really fun device. Funding has changed too. Now, instead of going to venture capitalists or funding things out of your pocket, if you're in this kind of middle spectrum of needing money, you can go to the crowdsourcing. To fund your project. CNC manufacturing has become less and less expensive. This is done by a couple named Jillian and Jeffrey who live in California, and they design office interiors for companies. These are chairs that have been cut by a CNC router that cost about $20,000. They get more business than they can handle, and they started it all for an investment of very little, a warehouse and a $20,000 CNC machine. Before, if you wanted to start a furniture company, think of the capital expenses that would have gone into it. Laser cutters are getting cheaper and cheaper. They're starting to get to be as cheap as laser printers. We have Quinn with us. Quinn started his own business, Q-Techno, and he makes all these really cool add-ons for Arduinos. My favorite one is the one in the lower right-hand corner. It's a fart sensor. You plug it into the Arduino, and it detects methane gas, and you can have it send an alarm or fire Nerf guns at the perpetrator. So take a look at some of these objects that people using this kind of phase 2 maker singularity technology have made. They really look slick and cool. They look like something that would come from a major consumer electronics company, but they were done without much of a centralized organization. They used these DIY organizational obliterating tools to do it. It's really impressive. Here are a few things that I've seen from kind of Maker 2.0 creations. This is a remote control cockroach kit. You can order this kit. They'll send you 6 live Madagascar cockroaches and this printed circuit board. You attach it to the cockroach. You can set it on the ground and steer it with a remote control. This is a device that's for people who are sight impaired, or if you want to walk around in the dark. Those are ultrasonic sensors, and there's cell phone motors in there for vibration, and there's an Arduino, and when you move your hand around, if you bump into like this box, it will start thumping to warn you that something's in the way. The guy who made it, Steve Hofer, put it together in just a couple of weeks, and he did it. The parts in there are under $100. Just think how much it would have cost to prototype something like this 10 or 15 years ago before we had these tools and technologies. It would have been astronomical. Steve also made the secret knock gumball machine. You don't get a gumball unless you know the secret knock. This is a really great example of what can be done when you get people in maker spaces and these kind of technologies together. This is a Geiger counter with a GPS unit in it. A hackerspace in Los Angeles and a hackerspace in Japan got together after the Fukushima disaster and made these things after a bunch of iterations and prototypes. They've made several hundred of these. People attach them outside their car in Japan, and as they're just driving along on their daily commute or trips, it is logging radiation data points all over Japan and sending those to a database at safecast.com. And you can see here the map. These are the radiation readings on the island, and you can see where the disaster took place. They actually have 10 million readings now. I need to update this map. This shows you the power of what this kind of maker technology revolution can do. To make something like this, the Japanese government probably would have spent millions and millions of dollars to do. These guys did for tens of thousands of dollars, and it's super powerful. Everybody's using this data. So I've been showing you all this really cool high-tech stuff, but this to me, this guy Scott Weaver really to me takes home what making's about. And he shows you that you really don't need all this technology to experience the joy of making. His entire kit of tools and materials are a knife, glue, and toothpicks. What you see there, that's it. And here's what he makes with these three things. This is a three-dimensional model of San Francisco, and you can drop marbles in it, and the marbles roll down these little paths that go and visit all the highlights of San Francisco. And so when I saw this, I said, Scott, this is awesome. I love it. Can I take your picture so I can show people who you are? And he said, yes, but let me put on my costume first. He's like the maker to me. He represents what making is all about. So thanks a lot, everybody. Have a great time here.
Thank you, Mark. Thank you.
Thank you
So,
very much, Ricardo.
this is an espresso for you.
Oh, excellent.
And the story is that when I discovered the book written by him, it's made by hand.
Yes,
Yes, it tells a story when he moved to Rarotonga in an island in the south of the Pacific.
Yes, that's right.
And then he started this process in the maker's world. And you've been investigating about the formula of the perfect coffee.
That's
and
right.
What did you learn? This is a perfect coffee, probably.
Oh,
an Italian
excellent.
espresso,
I
if
cannot
you want.
wait. Okay.
What did you learn about the formula of the
Curious.
perfect coffee?
I learned that there are several variables you have to lock down, but one of them is the water temperature is really important. And so hackers and makers have designed, have modified their espresso makers so that they can keep the temperature of the water variation at 0.1 degree Fahrenheit difference. Most espresso machines are about 40 degrees Fahrenheit. No good.
So you want to taste it? Let's see. Is it a maker espresso or not?
Terrific.
Terrific. Okay.
Delicious.
Okay. Thank you.
Thank you, Ricardo.
Thank you. Thank you so much.